My name is Kyle Baxter. I am a senior product manager here at Juniper working on our Apstra solution. And with me, I have Rajeev.
Rajeev. Hi guys, I'm Rajeev and I am part of the engineering group. My team mainly looks into telemetry and device lifecycle management.
Thanks, Rajeev. So today, I'm going to teach everybody how you can be an operations superhero. And so make sure you ask the hard questions. We have Rajeev. We have the team that built the stuff that I'm going to talk about in demo today. So we have the experts in the house. But you've heard us talk a lot about deploying networks and designing and building. And while that's incredibly important, because the more time you spend in designing, the easier it's going to be to operate your network later on, because you don't want to go back and design and rebuild it over and over again. So the hope is with Apstra, you can design it once, but then you're going to need to continue to operate it. So there is a lot of need on how do I continuously operate and manage and know my network is operating as expected. So that's what I'm going to talk about today is two new features that we have coming up, one that's already available and one that's about ready to come out, on how the first one is how you can be able to manage and capture, collect, and analyze anything in the network. And we'll see some use cases on that here in just a second. And then I'm going to sneak peek into a new feature coming up on flow. So with that, as I said, operations is already a key pillar of Apstra. And we have intent-based analytics. So IBA, when you see the word IBA, that's what it means, intent-based analytics. Probes that collect, analyze, enrich data. We have several that are on out of the box, things like that monitor device health, things that monitor your traffic, those kinds of things. We have ones that are specific to what choices you make when you deploy. So there's about 30 plus others that you can turn on demand. So things like if you pick an EVPN VXLAN fabric, you can have it monitor type 3, type 5 routes. If you're using optics, you can have it monitor those optics, those kinds of things. But what about the use case if I want to manage something out of the box? So if you just heard James' session, if you missed it, go watch the replay. But things like AI clusters. And so there's very unique things about an AI cluster. And there's probably unique things you want to manage like buffers and QoS and all the specific protocols that are in an AI cluster. What do you do? So let's pop the virtual hood of Apstra and see how data is actually collected. So telemetry data is ingested in Apstra via services called collectors. And you can see some screenshots of Apstra in here, things like we collect ARP and BGP and MAC and interfaces and LLDP, standard things that you would expect. And we use those to wire them into our intent-based analytics engine. And we'll see that in a second, and you'll see that the power that can provide. But if you want to go build your own, up until just recently, we had an SDK. But how many of you are Python gurus? Yeah, Rajeev, you should be raising your hand. But other than Rajeev, who's on the development team, the rest of us might be able to dabble in some Python, play around with it, but we're not developers, right? We're operators. Well, we have documentation on how you can do it, and you can use an SDK and write some Python code. That's not what the use case of what we're getting back from the field. So people tell us like this, dude, I'm not a developer. I'm an operator. And so what we're releasing and what we just released is a feature called Custom Telemetry Collector, and it tailors to that operator experience. So we'll keep those SDKs for those that love writing Python, but just now in our 4.2.0 feature, so you can go download this now, you can go try it in our demo platform, Apstra Cloud Labs, and you can see this in action today. But at a high level, this is a UI-driven workflow that is based on CLI commands, and I'll talk just a second on why we're using CLI commands, that you can customize and pick which devices you want to run it on, and then we'll see the true power of how you leverage that with our IBA engine, that intent-based analytics engine. So just a quick side on why we're relying on CLIs. So everybody's familiar, you know the CLIs. If I ask any operator, what do you do when you get the call that your network's outage? There's a list of show commands you're going to run. Everybody knows those. So everybody's familiar with those. They have the coverage. We are actively looking at ways we can use some of the streaming capabilities from devices going forward, but CLI is the easy way to start, and that's what everybody knows. That's what we're starting with today. So we'll see that here in the demos. So the first step is starting with identifying your source of data. And so just now in our newest releases, you can now execute CLI commands directly from the Apstra UI. So no longer do you have to open up a separate terminal session, run a command, capture the output, copy it, whatever. You can now natively do it within Apstra. So this is our first step, building block. You can now run CLI commands in Apstra. All right, that's great. So now we can use that. We can define a collector, and it's 4 easy steps. But you start with defining a new collector. And in there, you have to define a key and value pair. So like anything, keys, what you're looking for, the value is your output. So I'm going to go through an example. We're going to use a command called show BFD session. So that command, if you're familiar with it, shows a list of neighbor IP addresses in a state up or down. Pretty simple. So those neighbor addresses would be our key. That's what we want to look for and what we want to key off of. The up or down state is the value. So that's what we use for our key value mapping pairing. And because up or down is a string, the value type we put as a string. It's not an integer. And so we give it a human readable name for our key. We just call it neighbor. Then we can specify the target platform. This is how we specify which devices in our fabric we want this to run on. And then we put in that command. We're going to use that show BFD session command, and you see the schema all loaded there. So then finally, we have to map that schema, that neighbor and value to those keys and values we set up in the beginning. Okay, you're probably going, all right, you mapped some key values to a show BFD session. Okay, great. What can you do with that? So let's look at that, because the true power is when you wire those collectors into an intent-based analytics engine. Because when you add analytics to raw data, that's when it becomes useful. And so that's what we're going to do. We're going to create an intent-based analytics probe, and then we're going to wire processors on top of that. So there's a whole list of processors that you can see that we can add to it, from things like ranges, counts, min, max, averages, comparisons, and so forth. You can see the whole selection there of processing we can do on raw data. And that's really where we get the power and the value. So let's see it. Let's start here. Then we're going to create a new probe. And so we'll give it a name. And I'm going to fast forward through a little bit of this just because of time. So here we've already given it a name, and what we're going to pick is a graph query. So this is picking what devices in our fabric we want it to run. And so if you're not a graph query expert, don't worry. They're all labeled. There's already preset queries that basically cover everything you can need. If it's not, there's an easy graph building tool that we have in Apstra to go build your own queries. But this is how Apstra is built under the hood, is a graph database. So you do have to pick the query you want. And so as you can see here, I'm going to pick all managed devices. So I didn't have to know how the query, I just picked it, and ta-da, I have it. So then the next things I need to do is assign it, what are the system IDs, and so it's almost always system.systemid. Then we give it a service name. This is that collector that we defined just a couple minutes ago. And now then I think we got to put in what the value is, or the data type, which it's a string, and it's a dynamic string because it can be up or down. So we've added in a couple little fields here, and what we'll see is we've now defined a probe that'll go out in this case, it'll be every 2 minutes, but you can define the intervals, and run that show BFD session on all our devices in our fabric and collect states. So here you can see on leaf 2, all the neighbor addresses and the values. So we've collected a bunch of information. The next thing we're going to do is we're going to enrich that data. And so, like I said, Apstra is built on a graph database underneath, and what we have in that graph database is relationship information about everything in your fabric. So what devices are connected to what, via what interfaces, what links, all this information. So what I'm doing here is picking a more interesting query that has information about that neighbor address. So things like what is the interface it's on, what is the device role, what is the remote device, what is the remote device name. So what I'm doing is pulling all that information. So I'm going to skip ahead a little bit here. And you see I've added 4 additional keys about local interface, local role, remote interface, remote system. So you're going, "Oh, that's kind of cool," but what this has done and the power this has done is we've now combined pulling information from a show command on the device to information that Apstra knew about. So we've overlaid that information to give you even more information and more power. So now you can see, I know it's a little small. Let me see if I can zoom in here a little bit. You can see there on Leaf 2, it's to a generic device, what interface, what the remote system is. Looks like it's a router, some kind of gateway on the remote interface, what the IP address is, and the value. So not all that came from that show BFD session. All I got from the show BFD session was an IP address and a value. But that other information I got from the graph database in Apstra. So that's some of the value that we can pull in. We can combine that information together. So now you're probably going, okay, interesting. You've combined information from a show command with information that's already in the Apstra graph database and combine it into something more powerful and useful. But what else can I do with it? And this is where we can add those additional processors that I mentioned, that whole list of processors. Because it's like when you're looking at this pile of Legos, if I ask you about, what do I have there on the data side of it, you would just be like, I got a pile of Legos. I don't know how many colors I have, what color more than the others. I don't know anything. But the values, when you start sorting it, arranging it, presenting it visually, enriching it, that's when you start getting value out of your data. Because just collecting data isn't useful. It's just data. But when you do something with it, that's when you get true power. So that's what we're going to do.
Are there any usage limitations or
Yeah.
having run SaaS products at scale? I know if you set your customers free on being able to do a bunch of gnarly graph queries, you find out really quickly that people don't know how to write good graph queries, and they will ravage your system performance.
Yes, we actually thought of that, and we have an IBA probe, intent-based analytic probe, that monitors the other probes. So we wrote a probe to monitor ourselves, so that way we can check your probe health. And so say you have it running, say you have it set in an interval every 10 seconds, and it's an intense command. Or maybe you set it even every second. You want it to run every second because you want to know instantly what's going on. But it's overloading the device. Well, we'll see 2 things happen. We'll see maybe CPU spike in the device because we're monitoring that. We'll also see, your health of your telemetry service, that collector is probably degrading. So we'll see it like you may be pulling it every second, but it takes a second and a half to respond because it's an intense command or something like, is that kind of an example? Then you can start seeing, oh, I'm falling behind, and it starts alerting you, and you'll get alerts that, hey, you're degrading either Apstra or the devices because you're overloading it, doing too much.
It's like the good old days. We used to overload the span port, monitoring the other ports.
Yeah. So in this way, we monitor ourselves. But here I'm going to show you how you can add additional processors. So we're going to add 2 processors here. The first one is a count processor. And so this would be counting the sessions. Because we saw, example, earlier, like Leaf 2, it had a whole bunch of sessions. So it was nice that we listed them all out. But what if we wanted a simple count? This is what we can do. So we can add a processor, and we can call it count. And what we'll do is we'll give it then a name. And again, I'm going to just fast forward a little bit here. And what we're going to do is reference our, I'm going to jump right here. And we're going to reference our existing start probe that collected the data. And we're going to say count the number of states that say down. So then we get a count. And so now, Apstra instantly builds a nice little visual. You get gauges that show you how many of them are down. So we can see exactly on Leaf 2, we have 6 sessions that are down. And on other ones, we have no sessions that are down. So the next processor that we're going to create is called range. And so this is where we can use to say and alert ourselves if some kind of threshold is crossed. So in this case, we don't want any down sessions. We want them all to be up. So what we're going to do is create a range processor that is going to look for, you can see, I want it to be more than or equal to, you could say less than or equal to, you can pick some variables. And, oops, I didn't mean to click advance. I meant to, let's see if I can go to play. And here goes. So the range. And so we'll pick more than or equal to 1. So we want to be alerted when there's more than one session down on a device that we're monitoring for. We want it to raise an anomaly. And the other cool thing we can do is add metric logging. So this is historical logging. So we can look back in time up to a full year or any interval in between, hours, days, or up to that year, where we can look back in history. So now what you can see there is we now have the ability to, if I go back just a second, right there, you can see their gauges on different devices where some are red and some are not. So the ones that are red have more than that threshold that we set, 1, because we want to know when any of them cross that threshold of 1. So we can see leaf 2, it has 6 out of 10 that are down. Spine 1 has 6 sessions, but they're all up, so none of them are down, so that one's fine. So then even if I fast forward a little bit in this demo, we can then just look at anomalous ones that have crossed that threshold that we cared about. And we can see, there's 2 devices, leaf 1 and leaf 2. Our other leaf devices and our spine devices are fine from what we defined, but those are the 2 devices that we probably need to look at. So because this is part of our intent-based analytics engine, we can then add this straight to our dashboard. So this is where in the previous session, if you missed it, go back, watch James' session on building AI clusters. You could do something like this. You could build your own collectors based on what you care about in an AI cluster. You could then be able to build anomalous ranges where you care about and build dashboards. And this is exactly what we're doing. And James showed a quick little preview of it, but this is where we can get to of being able to build this. And so you can now, with this feature, any command you care about, you can collect the data and build dashboards to report on what you're caring about. And it can constantly poll and alert you when thresholds or when something changes that you want to be alerted on.
So I got a couple of comments on what I've seen.
Yeah.
So one, again, this is great for someone that obviously knows how to work with this particular tool. But as you mentioned, if it's actually monitoring the queries that I've built, just in case I made a mistake, then why not take the next step and actually go ahead and create a dashboard for the customers as part of this portal that covers I would say the very popular things that you would look for. And if it requires any sort of, fairly small or quick setup in terms of, determining the devices and so on and so forth that needs to actually being, visualized in that dashboard, just set it up as some sort of a wizard with relevant questions, and don't let me start typing in certain stuff that might be right, might be wrong. The query can be all messed up, and just make it a whole lot easier. So there's just one comment. The second one would be to actually go ahead and export this to to other tools, visualization tools that would be just popular within the organizations, instead of having a separate dashboard to look into that type of equipment. So just for example, having it exported to Grafana, just as an example. Is it something that's possible?
Yes. So I'll start with your second question. Can you export it? Yes, we have availability via, we have streaming capabilities coming from Apstra via gRPC. We have syslog. We have APIs. So there's multiple ways to get the same information out and into, if you have other tools you're using for monitoring, absolutely, we have that capabilities. So on your first part of your question, yes, we are looking at ways to simplify and streamline some of those UIs we saw to make it even easier and foolproof in a way. We're also, we'll take probably popular examples and we'll add them to the pre-built IBA probes that we have in the product. We're also potentially looking at maybe could we, we already have, Git repos with other things like the Terraform information. Could we have, those as being popular spots that for custom built probes, we have those uploaded to there where people can download them and import them. Those are all things that we're definitely considering. So yes, very good feedback. Thank you.
That would be very helpful.
One more quick thing. So I'm going to try to do this in like 2 or 3 minutes and wrap up with one more cool thing that we are working on. So we've talked a lot about operations. We have out of the box to monitor the health of your devices, your infrastructure with the custom telemetry collector. We can get any other services, show commands that you have. But the key, and we talked about this in some of the other sessions, and go watch the recordings if you missed those, is what about what's going on with your applications? And so we teased this a little earlier. So I want to show you what we're working on as far as collecting application flow data. And so this is things about understanding, why is my service slow? Who's consuming what? Am I getting bad attacks from the outside? What about cost from usage perspective? So we are adding a new feature called Apstra flow data. And so this will be collecting things like SFlow, NetFlow, IPFix, IFA, and from any vendor. This will work with any vendor that Apstra supports. We can collect that information and visualize that. So I'm going to show you a quick demo here, and this will be the last thing I have, on how this looks. So we'll start here. We are on our dashboard of visualizations. So this is our visualization of all that flow collection that we are getting. So if I find the play button, I'm going to go through a couple different tabs. And so I'm going to flash through them real quick, but we'll go through a couple examples of how these are used. So you see things like top in, core services, threats, flows, geography, graph relationship information, various different ways that you can interpret this flow data. And so let's start with an example. So what if you want to look at a specific service like SSH? So you can create filters. And so we'll filter on SSH as a service, and we'll automatically see all the dashboards change. And we see that there's some resets. Well, in SSH, resets are not a good thing. So we can dive into those, and we have filters across the top. And as we go against the different dashboards, those filters persist, and we can look into specific things about that filtered flow traffic. So in this case, we can look at it in a specific SSH reset issue, and we can see the details. So let's clear the
Just
filter.
a quick question.
Yes.
Maybe a dumb question, but are we looking into something? I'm just not familiar with that particular tool. Is it the data we're looking at is something that is proprietary for that particular tool? Because I mean, it looks like something that I can find in ELK if I stream that data over there. So what's unique about what we're looking at?
So what's unique about it is the enrichment that we're adding to the data. So the data isn't proprietary. It's using common SFlow, NetFlow, IPFix protocols. That's all standard, right? That's been around for years. Devices can stream it, and you're right. There's other things out there where you can visualize that data, but it's collecting it all for you and enriching it. What we found is talking to a lot of customers is most people, they might collect it by hand or when necessary, but they don't have a good way of collecting it, enriching it, and visualizing it. So that's really where the differentiation comes in, is that some of the enrichment we're doing for like geolocation, threat analysis, those kinds of things is where we're doing some of the additional value. Does that help?
Yeah, maybe a follow-up on that one. So, I mean, obviously we're talking about, quite a lot of logs. So, I mean, would you have to actually go ahead and set up something that is proprietary for the tool to actually go ahead and receive all that stream of data, then start, aggregating it so you'll be able to visualize it, or you can rely on existing setup of, again, example, just an ELK that would have those logs.
Yeah, so the speaker's breaking out a little bit, but I think I understood your question slightly, so I'm going to try to answer it, and if I don't, try repeating it. They're playing with the speaker right now.
Okay.
But as far as setting it up, it's not using proprietary things. Like I said, it's just things like SFlow. It's been around. It's configuring SFlow on whether it's a Juniper device, a Cisco device, or an Arista device, and setting it. How often you want to sample the data, how often you want to send it, those kinds of things. And then we collect it, enrich it, analyze it, and enrich it. So I don't know if that fully answered, but maybe the speaker's fixed again here. So if that didn't quite answer it, try asking again.
No, just again, just a clarification. So does it need to store it somewhere, or is just it just looks at the string?
Storage. So yes, we're using OpenSearch database, which is an open source version of Elastic, to store the database. But this is built like Apstra from our previous sessions, if you remember, is an on-prem application. So this would be an on-prem, not cloud consumed. So that way you're not eating cloud cost potentially for the large amounts of data. So this would be just storage you have locally in your data center.
Thank you.